Sentence similarity 3. So here's a question, right? So you're given two strings, sentence 1 and sentence 2, and you're supposed to return whether both of them are going to be similar. What a similar sentence means is that if it's possible to insert an arbitrary sentence into the shorter string one time such that both of them are equal, then they would be similar. If they are not, then they're not going to be similar. So let's go to an example. So we have strings hello Jane and hello my name is Jane, S1 and S2. So we notice that the shorter one is S1, and we can make it the same as S2 by inserting my name is inside S1. Right, so this was only one insertion, and we notice that both of these strings are equal now. Another case will be this example, where we have eating right now and eating, right? So I'll just type it out here. Right, so we have these two sentences, eating and eating right now. Notice that we can make S1 equals to S2 by making one insertion, which is of right now, into S1. So now they're going to be the same, right? This can also be done on the left side also. So let's look at an example where they are not equal. So we have a sentence which is off here, right? Then the second sentence is going to be a lot of words, right? So we notice that it's not possible for us to make S1 equal to S2 only by using one insertion, right? So let's say if I add a lot here, which is one insertion, it's not going to be the same as a lot of words, and you need another insertion to put the second word in, right? So in this case, we notice that they are not going to be similar. So now that we know like the basic idea of what we're trying to solve, let's see how we can solve it. So let's look at a positive example, which is going to be hello Jane and hello my name is Jane again. So what do we notice that is common, right? We can see that the prefix and the suffix of S1 and S2 are exactly the same, right? So here we have a prefix of hello, right? Hello is in the front, which is the same, and hello in S2 is also the same, right? If we look at the prefix, Jane is the same and Jane is the same, right? So what this means is that let's say we find out that that the prefix and the suffix are the same, then we can just insert whatever is remaining from the longer string inside, and if we do that, then we will know that they're going to be the same, right? But let's say if I have a scenario where S1 is equal to this, right? Well, OF and S2 is going to be this, right? What do we notice in this scenario? We notice that the prefix and suffix are not the same. The prefix of S1 is going to be off, and is not the same as A, right? So it's off. It's not the same as suffix of S2, which is off and words, right? So they're not going to be the same. So you realize that like as soon as you can kind of figure out that the prefixes don't match, or the suffixes don't match, then you kind of like figure out that sentences aren't going to be similar, right? So when do you know that sentences are going to be similar, right? So let's look at the first example again, right? So let's look at let's look at a way to approach this. So if you see hello and hello are the same, so let's assume that we can just remove them out, right? We just take out hello and hello, right? So now we have Jane and my name is Jane, right? So now the prefix is not the same, like Jane is not the same as my, but we know the suffix is the same because Jane is the same as Jane, right? So now we see that one of the strings has become empty and the other string has some values in it. So when you get this scenario where you compare the prefix and suffixes, and then at the end of the entire while loop or iteration, or what you do to get this result, you notice that one string is empty. You notice that it's possible to make S1 be the same as S2 by just simply adding whatever was here into here, right? Then because the prefix was what's added into it, right? is going to be this, and then plus suffix, right? So we know that the prefix and suffix are going to be exactly the same. So when we do this, then we can kind of like be sure that both of these two strings will match. But in this case, let's say we have off and a, prefix doesn't match, also suffix doesn't match, right? So in this case, we kind of know for sure that there is no way to create something like this, and sentences aren't going to be similar, right? Like you cannot make both of them the same by only using one insertion. Okay, so with that now out of the way, let's look at how we can solve this problem, right? So the first thing I like to do is split the sentence from a string to a list. So I'm using Python here, and in Python I can use the split function to split a string into words. So S1 will contain a list of what sentence of the words of the sentence, all separated by a comma. So what it does is, like, let's say we have my name, let's say we have like a lot of words, right? This will be kind of just converted into a lot of and then word. So we're pretty much just splitting up the string into a list, right? So I'll just call this S2 list over here for this example, right? So yeah, so that's how the split operator works. So the good thing about this is that now we don't need to deal with like the white space in the middle manually, so this is all automatically taken care of, as we assured in the question also. So we can so to approach the prefix suffix problem, we can kind of like do a two-pointer approach, right? So we will have 4 pointers. L1, which is going to be 0. L1 is going to be the left pointer of string 1. R1 is going to be the rightmost pointer of string 1. L2 is going to be the leftmost pointer of string 2. And R2 is going to be the rightmost pointer of string 2. So we initially set L1 equals 0 as we start at the left of the string, and R1 is len S1 minus 1, as that is the rightmost point of string S1. So let's say if we have string of S2, right? Length of S2 is going to be 4, and 4 minus 1 is 3, and 0, 1, 2, 3. So the pointer will be at this point, which is the latest suffix, right? So once we have these 4 variables set up, we can have a while loop. So my while loop it will just break when we beat either of these conditions, right? So I'll first go through the case where we see a matching prefix, right? So if S1 L1 is equal to S2 L2, we know that both prefixes match, right? So when we know that both of these prefixes match, which means that we can progress both of these pointers forward, as we know that these prefixes are the same. This is pretty much like in effect what we're doing on top here, right? Like we had hello and hello here, so we just imagine you're just removing the hello by increasing the pointer forwards, right? So now we go to the next point in the string. So yeah, so we progress L1 and L2 point forwards, right? This is the case. This is to check for whether the both of the suffixes match, right? So this is if S1 R1 is equal to S2 R2, and then we just minus equal to 1, right? If they match, cause we just go backwards. So here we knew that the suffix here is Jane, and it's Jane, so you want to like move backwards for the next suffix, so minus equal to 1 and then minus equal to 1, right? So that's how we progress the pointers. And as explained in this example, with between off and a lot of words, right? It's in the case where the prefix and suffix do not match, then we just return false. We know that there's not a way for us to make the sentences equal, right? So then we can return false. And then the case, the breaking point of the loop, where we know the sentence can be formed, will be found out if we get an empty string, right? So in this case, we had an empty string. Remember, after we went through the common prefix and common suffix, we had an empty string here. How can we check out whether an empty string has been achieved? It's just simply by checking whether the right pointer is now less than the left pointer, because if the right pointer of a string is less than the left pointer of the string, which means that the string is now empty, right? So if either the left string or the right string is empty, then you can return true. So that is how you can solve this question. So let's look at the space complexity first for this question, which is going to be of linear time, as we are only storing both S1 and S2 as lists, right? Which are going to be of maximum of like linear length based on S1 and S2 size, right? And in terms of the time complexity, it is going to be linear as well, as we only have one for loop, and we either progress the as we either progress both pointers forward or backwards, or we break out the entire thing entirely, right? So the time complexity is going to be, okay, let's say if S1 has size m and size S2 has size n, and time complexity is going to be om plus n, and space is also going to be om plus n as well. So that's how you solve this question. Hope you enjoyed watching this video, and have a great day ahead. Bye bye.